Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x equals 5 to the power of 2x. And what we're first going to do is we're going to simplify this right-hand side of it. We have 5 to the power of 2x. And if you guys already didn't know, an important property of exponents is that if we have a to the power of b times c, this can be written as a to the power of b to the power of c, and also vice versa. It could also be written as a to the power of c to the power of b. So what we're going to write this as is, well, let's first write our 3 to the power of x, and this equals 5 to the power of 2 to the power of x. Now, 5 to the power of 2, as we all know, is 25, right? So this is 3 to the power of x equals 25 to the power of x. Now what we're going to do is we're going to divide by 25 to the power of x on both sides. So we're going to divide this by 25 to the power of x. And remember, what we do on one side, we do on the other side. So we're going to divide this side by 25 to the power of x. So now we have 3 to the power of x over 25 to the power of x equals 25 over x over 25 to the power of x. And remember, anything divided by itself equals 1. So these two cancel out, and this just equals 3 to the power of x over 25 to the power of x equals 1. Now, whenever we have something like this, and we have our numerator going to the power of an exponent and our denominator going to the power of the same exponent, we can rewrite this as 3 over 25 to the power of x equals 1. Because the x, it just multiplies with all our numbers here. So this is equal to this. And now what we want to do is we want to make our bases the same. So another way to write 1 is 3 over 25 to the power of 0. And that way, both our bases would be the same. So this is equal to 3 over 25 to the power of x equals 3 over 25 to the power of 0. Because remember, this is equal to 1, and now we changed both of the terms so that they have the same bases. And now, because both of these terms have the same bases, we know that their exponents are equal to each other, because if they weren't, then this would be false. So now we could just ignore these two bases and set these exponents equal to each other. So x is equal to 0. And this is actually our answer, because we can't simplify this anymore. This is our answer. X is equal to 0. Now, why don't we plug this in and check? We have 3 to the power of 0 equals 5 to the power of 2 times 0. 3 to the power of 0 is 1, and this equals 5 to the power of 2 times 0 is 1. 2 times 0 is 0, and 5 to the power of 0 is 1. So this is 1 equals 1. So this is right, meaning our answer is x equals 0. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of x to the power of 4 equals 64. Now, what I'm first going to do is I'm going to take the fourth power of both sides. So we're going to take the fourth power of x to the power of x to the power of 4 as well as 64. Now, an important property of exponents is that if we have a to the power of b to the power of c, this is actually equal to a to the power of b times c. So what we're going to do over here to x to the power of x to the power of 4 to the power of 4, we're going to multiply x to the power of 4 times 4. Because in this case, x to the power of 4, this is b, and 4 is c. So this would equal x to the power of x to the power of 4 times 4. And this is still equal to 64 to the power of 4. Now, what I'm going to do is I'm going to switch this so that it's in the form x to the power of 4 to the power of x to the power of 4. As you can see, all I did was switch the order. Before it was x to the power of x to the power of 4 to the power of 4, and I simply switched the order of 4 and x to the power of 4, and that is completely legal. And this is still equal to 64 to the power of 4. And notice how x to the power of 4 and x to the power of 4 are the same, right? Well, I actually want to convert this equation so that it's in the form a to the power of a equals b to the power of b. Because if it is in this form, then we could just set a equal to b. So we already have x to the power of 4 to the x to the power of 4, so we already have a to the power of a. Now we just need to convert 64 to the power of 4 so that it's in the form b to the power of b. So 64, this is equal to 8 squared, right? So we're going to replace 64 over here with 8 squared. So we're going to have 8 squared to the power of 4. And we're going to use the same property, a to the power of b to the power of c equals a to the power of b times c. So 8 to the power of 2 to the power of 4, this would equal 8 to the power of 2 times 4, which is 8. And we still have x to the power of 4 to the power of x to the power of 4. Now we can say that if a to the power of a equals b to the power of v, a equals b, right? So if x to the power of 4 to the x to the power of 4 equals a to the power of 8, then we know that x to the power of 4 equals 8. Now we want to cancel this fourth power here, so we're going to take the root of 4 on both sides. Now these two would cancel out, so on our left side we would have x, and our right side we would have equals positive or negative, remember it's plus or minus, the fourth root of 8. And this is our answer.